Greetings, my name is Milan and today I will take you through an overview of descriptive and inferential statistics and their day-to-day application. In today's video, our agenda is to look at statistical principles, to be precise, descriptive statistics and inferential statistics, including day-to-day statistics application. Statistics is a discipline of study dealing with the collection, analysis, interpretation, and presentation of data. Statistical methodology is utilized by posters who sample our opinions concerning topics ranging from art to zoology. Statistical methodology is also utilized by businesses and industry to help control the quality of goods and services that they produce. Because of its broad range of applicability, a course in statistics is required in a number of disciplines. Today, we are going to learn about descriptive statistics. Descriptive statistics are methods used to summarize, organize, and present data in a meaningful way. Instead of looking at raw data, which can be confusing, descriptive statistics help us understand patterns quickly. Descriptive statistics help to reduce our information to a manageable size and to put it into focus. Some of the charts used in descriptive statistics include pie chart, bar graph, and histogram. Descriptive statistics also comprises computation of measures of central tendency, such as the mean, median, and mode. The mean, also known as average, is calculated by adding all values and dividing by the number of values. The median of a set of data is the value that divides the bottom 50% of the data from the top 50% of the data. To find the median of a dataset, first arrange the data in increasing order. If the number of observations is odd, the median is the number in the middle of the ordered list. If the number of observations is even, the median is the mean or average of the two values closest to the middle of the ordered list. The mode is the value in a dataset that occurs the most often. Let's now look at inferential statistics. The complete collection of individuals, items, or data under consideration in a statistical study is referred to as the population. The portion of the population selected for analysis is called the sample. Inferential statistics consists of techniques for reaching conclusions about a population based upon information contained in the sample. Descriptive statistics help you describe what you see, but inferential statistics lets you make predictions, test ideas, and generalize beyond the data you collected. Statistics, the science of collecting, analyzing, and interpreting data. Every statistical journey starts with two big branches. On the left, descriptive statistics, and on the right, inferential statistics. Let's break them down further. Descriptive statistics do exactly what they sound like. They describe your data. They help summarize the information you already have without making guesses beyond it. Let's take a dive to measures of central tendency. Measures of central tendency tell you where the middle of your data lies. The mean, also known as the average, is the sum of data values divided by the number of values. The mode tells us the most frequent value, and the median tells us the middle number when everything's in order. Then we have measures of variability, which tell us how spread out our data really is. The range shows the gap between the smallest and the largest. Variance and standard deviation tell you how much scores typically drift from the mean, and the interquartile range focuses on the middle 50% of your data, ignoring outliers. Descriptive statistics rides on the construction of various charts, such as a pie chart, histogram, and bar chart. A pie chart is a circular diagram divided into slices, where each slice represents a proportion or percentage of a whole, making it useful for showing how different parts contribute to a total. A histogram is used to display the distribution of continuous data by grouping values into intervals, helping to show patterns such as frequency, shape, and spread. Making it easy to compare different categories. Now let's take an in-depth look at inferential statistics. Unlike descriptive statistics, inferential statistics lets you take a small sample and make educated guesses about an entire population. First up, we need to know that probability distributions model how data is expected to behave, from the familiar bell-shaped curve to other shapes. Hypothesis testing is also an aspect of inferential statistics. It is also known as the backbone of scientific discovery. You test whether your observed results are real or just due to random chance. From describing what's in front of you to inferring what you cannot see, that's the power of statistics. Statistics plays a crucial role in weather prediction by helping meteorologists analyze large amounts of atmospheric data such as temperature, humidity, wind speed, and pressure. By using statistical models and probability techniques, patterns and trends in past weather conditions can be identified and used to forecast future weather. This allows experts to estimate the likelihood of events like rainfall, storms, or droughts, making weather predictions more accurate and reliable for planning in agriculture, transportation, and daily life. Statistics play a crucial role in sports by helping teams, coaches, and players make informed decisions based on data rather than guesswork. Through the collection and analysis of performance, data such as scores, player efficiency, and win or loss records, statistics enable the evaluation of individual and team performance, identification of strengths and weaknesses, and development of effective strategies. For example, in games like football or basketball, coaches use statistics to decide player lineups, track progress, and predict opponent tactics. Overall, statistics enhance fairness, improve performance, and increase the overall competitiveness of sports. Statistics play a central role in business decision making by transforming raw data into meaningful insights. Companies use statistical tools to analyze customer behavior, forecast demand, and set pricing strategies. For example, sales data can be examined to identify trends and seasonal patterns, helping businesses plan inventory and avoid overstocking or shortages. In marketing, statistics helps measure the effectiveness of campaigns, segment customers, and target the right audience, leading to more efficient use of resources and higher returns on investment. In industry, statistics is widely applied to improve quality, efficiency, and productivity. Techniques such as quality control and process optimizations rely on statistical methods to monitor production performance and reduce defects. Manufacturers use statistical models to predict equipment failures and schedule maintenance, minimizing downtime. Additionally, industries such as finance, logistics, and supply chain management depend on statistics for risk assessment, demand forecasting, and decision-making under uncertainty. Overall, statistics enables businesses and industry to operate more strategically, reduce costs, and remain competitive in a data-driven world.